Now let's try to find the deflection of a cantilever beam with a uniformly distributed load. In the previous case, we saw deflection of a beam with what? With a point load at its free end. Okay, the problem is almost similar, only the thing is the load will change. Okay, now let us just go for this one. Now let us just draw a beam over here. I have a long beam which is subjected to what? A uniformly distributed load of how much? W. This is how much? W per unit length. Okay, what is this length? This length is L. Let me take a section over here. Let me change the color. This section is what? XX, and let this distance be X. Okay, now I will call this one as A, and I will call this free end as B. All right, so as usual, what we have got? We have got our differential equation EI into d square y by dx square is equal to m. Okay, now what is the bending moment at xx? Bending moment, I will just go and write m x is equal to how much? What is the weight at mx? It is w into x. Okay, w into x. Where it is acting? It is acting somewhere exactly in the middle, is it not? What is this distance? This distance will be x by 2. Load multiplied by perpendicular distance is moment, is it not? Into x by 2. Since it is bending the beam downwards, it is minus sign. Minus wx square by 2. Okay. Now these above two equations let us equate. Let us equate above two equations. Let us just reduce the size. Size seems to be big. Yeah, this is okay now. Now what I will do is I will do the integration. So this is what EI into d square y by dx square is equal to minus wx square by 2. This is my first equation, is it not? Let me integrate it. If I integrate it, as usual, what I am going to get? I am going to get EI into integral of d square y by dx square into dx is equal to minus w by 2 integral of x square dx. Okay, now let us try to, what shall we do now? Let us let us write it over here. EI into dy by dx, there is a constant, I will take it onto the right side, minus w into x square means what can I write now? I can write it as x cube by 3. 3 and 2 becomes 6. So minus w x cube by 6 plus c1 I will call. Okay, now let us apply the boundary conditions. What are the boundary conditions? Where is your dy by dx 0? Your dy by dx is becoming 0 at point A, correct? So let's go back. I will just write it over here at, where is my pen? My pen is here. Okay. And the thickness also I need to change. Oh my god, what's happening to this one? At x is equal to 0, dy by dx is equal to 0. So what will happen now? So therefore obviously your sorry, 1 minute, 1 minute, let me just go back here. At x is equal to L, at x is equal to L, your dy by dx is becoming 0. Okay, so what I will do now, I will write at x is equal to L. So therefore what will happen now? I can just, let me reduce the thickness, it's bothering me. So I can write 0 is equal to minus WL cube by 6 plus C1. So therefore what will happen to the value of C1 now? C1 is equal to WL cube by 6. Okay. So now let us substitute it. So what happens now? You get EI into dy by dx is equal to minus Wx cube by 6 plus WL cube by 6. Okay, instead of C1. Okay. So integrate again. Integrate again. If you integrate again, what are you going to get now? If you are integrating again, you will get EI integral of dy by dx into dx is equal to minus w by 6 into integral of x cube dx plus w by 6 integral of and wl cube by 6 integral of dx. So this will give me EI into y is equal to minus w into x to the power of 4 by, you will have 4 4 6 are 24 plus WL cube by 6 into, instead of dx you will have x plus C2. Now again go back. If you go back to the top, you can see at point A you are having what? Your deflection is 0, is it not? So I can simply write when x is equal to L, y is equal to 0. Just go and substitute the value now. So you will have what? 0 is equal to minus WL to the power of 4 by 24 plus WL to the power of 4 by 6 plus C2. Okay. Now if you take the things on left and to the left side and right side, and when once you do it, what would be your value of C2? C2 will become, I will write it over here. Sorry, it's a real botheration now. I have to delete this. Okay. So I will just go back to my pen. I will put a line here like this and I will do it over here. So what can I do now? I can write C2 becomes is equal to how much? C2 becomes is equal to WL to the power of 4 by 8. Use this value into your equation. You will have EI into Y is equal to minus W x to the power of 4. Sorry, it's not doing a proper job. W x to the power of 4 by 24 plus WL cube by 6 into x, and then you have minus WL to the power of 4 by 8. This is your general equation for what? This is your general equation for EI into Y. Okay. So now when your Y is maximum, Y max at x is equal to 0, is it not? Therefore I can write Y max is equal to how much? Minus W L to the power of 4 divided by 8 EI. Okay. When is your dy by dx max? Dy by dx is max at x is equal to 0. Therefore dy by dx is equal to, you just go to the equation of dy by dx. Where is dy by dx equation? Dy by dx equation is here. It is here, correct? So dy by dx is maximum at x is equal to 0, is it not? So it will be EI into, where is that equation? We have to substitute in the value of hina. Okay, at this point. Okay, this is your dy by dx equation, correct? So WL cube by 6EI minus WL cube by 6EI. Okay. Is it minus or plus? Let us just see. 1 minute. Plus WL cube by 6EI. This is what? This is your maximum value. Right. And you have the general equations and you have the equations where you get maximum dy by dx and y max. Also, you will get where dy by dx is 0 and y is 0. You substitute the general equation, you will get the answer. You have to solve problems on this. That's it.